Thank you, everyone. During the lunch break, I was talking to many people, and the first question they ask is, are you nervous? And so I feel like right now I have an obligation to be nervous. So if you feel me fumbling, it's all your fault. So today, my topic is slightly different. I said I'm going to talk about compositing, but so there are two parts to compositing. There's actual compositing, and there's blend modes. And my favorite is blend modes, so that is what I'll be talking about today, and not the other stuff. As Peter mentioned, my name is Divya, and I'm a product manager at Adobe with a team, and that team is called Web Engine. And what we do is to contribute features that we think are useful on the web, but don't exist yet. And we contribute in both in specifications and also in implementation in WebKit and Blink, which means you may see these things in both Safari and Chrome. So some of the features we are working on include something known as regions, which allow you to throw content irrespective of the document source order into any container, which is similar to how you would have seen this happen in InDesign. When text overflows, you can make that text overflow into different containers. And we are also working on filters and blend modes, which is basically my topic for today. And so because we have made these contributions to the spec and the implementation, I'm I know slightly more than before of what these features do. And I also have access to my team members who actually know these things, so I can immediately ask them why something is working or not and how they work. So let's go into the first thing that I'll be talking about, which is the filter effects. And this specification came about from a task force known as the FX Task Force. What the task force does is basically it's a combination of the CSS working group and the SVG working group, where they look at what are the features that are available in one but not in the other, and how they can interoperate in much more closer manner. And the specification itself was created somewhere around 25th October, I think. It's pretty recent, it's 2012. But this specification, which is the filter effect specification, had its origins in what is known as the SVG Filters, which have existed for years together. And it was initially proposed by Adobe, but it's then since been worked on by people from Apple and also people from Adobe again, and which resulted in the new spec that is the filter effects spec. So so also some parts of the filter effects specs is available since Chrome 18 or Safari 6. So it's kind of available in some stable browsers, including some mobile browsers. So it's worth looking at what it does. So what is filter effects? The way it would work is basically it applies a set of filters on an element. So it is similar to the analogy of actually using filters on your camera and taking a picture is kind of still applies. And it basically changes the pixels of the element you're applying the filter on. So the syntax is pretty simple. You have a selector, and you have the property known as filter. And if you're using it on browsers, you need some prefixes. And then you have the image processing function. This is for a built-in filter, and it's called blur in this example. And then you pass a value to it, which would be 10px or whatever that filter function needs. So here's like a simple demo of filters. So if you notice, if I hover, it's getting very blurry, and if I don't hover, it's not so blurry. So let's look at the filter effect that's being applied. I have an effect on hover where I say the filter is blur is 10, so I can change to 40. It becomes even more blurry and things like that. So that's a very fairly simple example of built-in filter. So if you've seen that blur, you may say that blur is familiar to you because it is not new. In CSS, we've used that blur thing before. And we have hacked blurs with box shadows. We have seen blurs in text shadows as well. But the blur that you see with filter effects is different from these blurs, and I'll talk about that a little bit later. And so how do these filters work? So first, you have the element where you're applying the filter being rendered, which means that it is created as an image. because browsers ultimately display images on the screen based on understanding the code that you send them. And so this element, so you'll have the border radius, you'll have the gradient, you'll have the outline, and all of that things rendered on the screen, and then you'll have the filter applied on top of that. And then all the other features like blend modes, or clipping, masking, or opacity will apply on top of the filters. Now, when we go through this process, there is something you may, if you are clever enough, you'll be seeing, which I'm not, is filters create a stacking context. Now, how many of you know what a stacking context is? OK, a few of you. But that means I can be very clever and explain what it is. So here is what a stacking context is. It basically determines the paint order of the elements. So for example, you have a z-index. And then if you have a z-index, then the browser needs to determine which comes first, like which element is the z-index 1 or z-index 0. So this is a transition thing. But you can see that the red element needs to be painted first before the blue, Alice blue element is to be painted. So that is what stacking order determines. And there's a detailed explanation of that in the CSS 2.1 spec, which, if you're interested, you should be, and you should read more and find out. So stacking context is important. It's gaining in importance, and you should be knowing about this because a lot more specs will be taking advantage of this. And the browsers also use stacking context to determine if a certain element needs to be GPU accelerated or not. And so as an aside, if you have filters on an element and that element is animating, then it will also be GPU accelerated. So here is a demo on Chrome to see how that would look like. Here you see I have a timeline view, and I'm just recording the animation. If you notice, there is no repaint or layout, so it's all just compositing. So it's all happening directly from the GPU, so it's directly rendering this. And if you have the nightly the WebKit nightly, then you would, there's another interesting dev tool that I thought is useful to show, even though it is not, it's an aside, it's just fun. They have a layer, they have the tool called layers, and you can find out which of these elements are accelerated by the GPU, and it'll tell you the reason why it's accelerated, and the number of painting it does, and how much memory it has. It's just an aside I thought it would be interesting to know because it just got released. OK. So we've seen how filters are rendered, how they're displayed, but let's look at what do we have as filters. So there are three kinds of filters that are specified. The first is the built-in filters, and we saw a demo of that with the blur function. And the next one is the SVG filters, and I'll go through that a little bit later. And the last one that is specified is known as custom filters. And I'm just going to mention this briefly here because the implementation detail of custom filter is a lot more complex than we first imagined. So it's going to be a long time before we see this actively in a stable browser, especially because it delves so deeply with the graphics layer. And so, but I can show you a brief demo of what it would look like if it were to happen. And here it is. We made a demo that shows how custom filters would work. So you can see that it essentially is using GLSL shaders, which you usually see in WebGL, and have it apply on HTML elements. So GLSL shaders enable you to use textures that are like you can bend things out of shape, you can split things, and so on based on vertex calculations, and then apply that. It usually applies on a canvas element, but now here we are using it on HTML elements. So all of this content, this text, is all HTML. And if I move this, you can see that how this bends and moves. And it's the same with this as well. So I can move it like that. And you can have accordion effects. You can see how lighting works and the shadows. So all of this is working right now, but because of the changes, it's under the hood, it's a lot of complex stuff that's happening. So all of this animated calendar effects. So this is how it would work when it comes, but it's going to take a while. So that's why I went through that right now. So let's look at built-in filters then. Because this is fairly simple, and this support is more or less available in most stable Chrome and Safari, so this is interesting to look at. So it is basically a CSS shorthand reference for a lot of image processing functions. And there are a lot of built-in filters, not as many as you would like, but I mean, it's not Photoshop, but you have different functions like blur, which we saw, grayscale, sepia, saturate, hue rotate, invert, and many things. But I don't want to go through each of them to explain what happens, and I actually didn't do very well in my image processing class in computer engineering, so I'm not even going to bother explaining the image processing, how it works. But there are certain functions that I think are interesting that we should take a look at. And the first thing is Hue Rotate. And this is a function that I don't see many people take advantage of. And what it does, it basically rotates the color on an image by a few degrees on the color wheel. So you specify a degree value and to the function Hue Rotate, and then it will change those colors by a few degrees in the color wheel. And it does that by doing a series of matrix operations on your RGBA color that you provide, the input color for that particular element. So this matrix calculation happens for all color filters. So you have like grayscale, you have saturate, all of that will use a similar matrix calculation. So let's look at a demo of the Hue Rotate. So I hope you can see it. So let's hover on this element. Can you see the change in color? A little bit? Yeah, OK, good. So let's, again, look at hover. So you have a Hue Rotate, and I have a value that's a degree, and then I am just transitioning that filter for 1 second and using linear easing function. The interesting thing about Hue Rotate is it doesn't have a limit on the value you provide here. So 360 is not a limit, or it won't clamp. So I can do 3,600. And let's see, the interesting thing is it'll start animating much more quickly over the color wheel. So it's just going to be much quicker, which, oh, I have not saved. And let's. So if you notice that it just very quickly rotated over the color wheel. So if I specify only 36, then it'll be much, much more subtle than before. And then the other thing that is interesting is drop shadow. And so it basically is a blurred offset version of the input's non-transparent areas, which is the two official. But it is very similar to box shadow. So you may wonder why we have that. But so even if you look at the syntax, it says filter, then you have a drop shadow function. You have a syntax that's very similar to what you would use with box shadow, except there is no the spread that usually you have with box shadow. So let's compare these two. Why is this different? So on the left, you have box shadow, and on the right, you have a drop shadow. If you notice, the box shadow doesn't have the triangle as a shadow. It simply has that box, while the drop shadow has that triangle also with a shadow. So that seems to be like a very obvious difference. But there are also other differences in terms of implementation details. So box shadows are pretty optimized. And this is, I'm talking specifically about Chrome and Safari, but I'm sure other browsers do things to optimize the generation of box shadows as well. So if I have an element container that's a rectangular box and you have a box shadow on it, then the browser split that box into 9 separate images and create the blurs for each of those sections. So for example, you notice that here you have blurs for all the blue areas, and the inside of the box itself has no blur being generated. So which is why you see that effect that we just saw a few slides ago here. So it's only generating the outer blurs, and nothing is generated for the triangle. And this is much faster, so this is why it is done. thing is, the drop shadow function actually generates it for the entire element. So it would be if you have a transparent area within that element, so maybe you have an image that is transparent, then it will also generate drop shadow for that transparent area. So this is cool if you want to create like a much more realistic shadow effect. So we've seen drop shadows, we've seen box shadows. We know that there's blur that is similar, but in general, the CSS filters, the way they blur, is very different to the way the blurs apply in other CSS properties like box shadow and text shadow. And the reason is the way the blur radius is being used. So blur radius is the value you pass to the filter. So there is a blog post by David Barron who goes into greater depth on exactly why this is different. And the reason is that, OK, let's just go into what CSS blurs are, which is basically box shadows and text shadows as long as they have the blur radius. And Canvas also has a blur, so which you can set using the shadow offset and the shadow blur and so on. So there is a thing called standard deviation that is used in calculating the blur based on the blur radius that you provide. And the standard deviation is set to half of the value that you pass in as blur radius for your box shadows and text shadows. So that is straightforward. Except for filters, there is a complicated math that's involved. And this is not the only thing. This is not, there's also multiple conditions afterwards that come when you're calculating the standard deviation in filters, especially like the blur function that we saw and also the drop shadow function. So it's kind of different from how it is calculated. But for us, I don't think you will notice a significant difference unless you do like in-depth calculation or some image processing to find out the exact difference in the rendering of the blurs. So in terms of built-in filters, the browser support is not bad. You have the stable versions of Chrome, Safari, and now with Opera 15 Plus, you'll have that support as well on that, which is OK. We get almost there. But there is SVG filters, which can help us get even more support. So SVG filters have existed for a very long time. But the interesting thing about SVG filters is now you can use them as an input for CSS filters, which is use this filter property and use an SVG filter and apply it to an element. And all of these built-in filters that are specified have an equivalent SVG markup that determine exactly how they will be rendered. And so here's the blur filter. You have a filter property, and then you have the blur function. And if you notice, there's a SVG equivalent with the filter. And I mentioned the standard deviation, and there is an attribute called std deviation, and then it takes in the radius, which is the same value that you would pass to the filter function itself. So the good news is it works in Firefox and some other browsers as well. So, but this means you can start using CSS filters in a much larger context than before. And I did mention something known as, let's look back. Oh, here, this. You have the FE Gaussian blur. And that is known as a filter primitive. So built-in filters are defined in terms of these filter primitives that exist in SVG filters. And SVG filters has lots of filter primitives that do a lot more things. So here's a whole list of filter primitives that SVG filters provide. Those that are highlighted in bold are those that are used by your built-in filters. So you know there's a whole other set of filters that you could use if you're using SVG filters. And I will show an example of some of these insane filters in a while. So the advantages, as I mentioned, or I've not stopped mentioning, is you can use as an input in CSS filter. So here's a demo. I hope it doesn't crash. But, oh, no, this won't crash. So this is basically an SVG, inline SVG. You have an SVG element. Maybe you can see. OK. And I have a filter. Maybe I should remove. OK, that'll be better. You have a filter element, you have a bunch of filter elements, and you have a filter primitive. You have attributes, base frequency, and num octaves, or whatever. So here, what's interesting is I am using it as a property that I set on the div. And I just say filter, and I say URL, and I simply refer to the ID of that filter because it's inline SVG. And then you see that this filter is being applied. Now, I can change this to T2, and you'll see the other filter will be applied on T3 or T4. So all of these filters, the output that you see on the screen is based on these values that I'm passing as attributes for the attributes for each of these filters. And the fun thing is you can also make this work in Firefox, and I'm not sure why it's doing it for the entire page, but I'm doing the same thing, but also the bonus is I do it without a prefix, but the same syntax. And now you can see the thing applying on Firefox as well. And I don't know why that didn't work. Oh, it did. OK. So that's pretty useful. And you also have a lot more effects like morphing. It's insane what you can do, all the specular lighting and diffuse lighting and so on. And here is a demo. This is the demo. I hope it doesn't crash, which is basically manipulating the value of a SVG attribute. And so you can see all of these lighting effects on live text that's happening. This is simply an SVG document. And this is from SVG WoW site that is always shown as what SVG is capable of doing. But now, the good news is you can start using these kinds of cheesy Photoshop effects in HTML. So in terms of SVG filters, as the URL scheme that I mentioned, it's supported in IE10, which is good news. And there's also all unprefixed, which is even better news, and Firefox as well. But I think you need to have a prefix for the other WebKit browsers, Chrome, Safari, and Opera 15+ as well. So let's look at blend modes. So that finished my talk about CSS filters. And in terms of blend modes, how many of you have used blend modes? What, so few? Really? I'm surprised. So blend modes is a feature in Photoshop that you would have heard of. And usually, blend modes is what most designers use to prove they are designers, because you'll have multiple layers. You'll have multiple blend modes applied. You'll have overlay. You'll have like 10 different blend modes to create these interesting, intricate effects that you cannot create otherwise. And here are some examples of blend modes that are around the web. I don't know if you can see, but if you notice, there's a texture. And this text has that texture underneath it. And you have here, there's also some sort of the color that is being changed because on that particular text. And same with here as well. So these are what you would use blend modes for usually. And what blend modes actually do is basically it sets how colors mix when the source element and the backdrop overlap. Now I'll explain what each of those mean in a bit. But there are lots of blend mode values, and these, if you've used Photoshop blend modes, it would be very familiar to you. They are all very similar to the ones available in Photoshop. So you'll have normal, which means basically don't apply, like there is no blending happening. And then you have multiply, you have screen, overlay, darken, lighten, and all of this. So I mentioned source element. So the source element basically means the element on which you specify a blend mode. And the syntax for that would be you have an element as a selector, and then you would have a property called mix blend mode, and you'd specify the value of blend mode you're applying it on. So maybe you would have multiply, maybe you'll have darken, and things like that. Now it comes to the complicated question of backdrop. So if you have used blend modes in Photoshop, the way it would work is it would apply, it would blend with all the layers that is beneath that particular layer you're applying blend mode on. But again, we are dealing with a browser, so ideally this should be the case, so it will be like content that is behind an element. But so all the elements that are behind the source element are rendered into place as an image or a bitmap, and then blended with that element which has the mix blend mode property. Now, this seems like, oh, it's no big deal. This is normal. This should be how it works, except on browsers, we have complicated cases of where you have certain layers that are rendered by GPU and certain layers that are not. And this kind of operation is very, very expensive. So this is not very common. So we have restricted blend modes to their parent stacking context. So as I mentioned, stacking context is going to gain in, like you're going to learn a lot more about stacking context with new and newer features. So I did mention about stacking context. So the backdrop will only extend to the current stacking context. So let's see what all creates a stacking context. Like what is the stacking context created from? We did know what stacking context is, which basically determines the paint order. And if you have a Z-index set, obviously that would mean that that element creates a separate stacking context. Then if you have opacity or filters, if you have regions, if you have blend modes, if you have overflow set, if you have a transform, then all of these creates its own separate stacking context. So if you have a stacking context, it means you can only blend till that element that has that stacking context. So all of these properties that create a stacking context also create other things, like they have side effects. So if you have a Z-index that is set and you have a position that is it's absolutely positioned, then the child elements can only be positioned within that container. And if you have filters, then obviously a filter is being applied. So because they have these side effects, then you don't want to hack your backdrop. You don't want to say, oh, this element will be the backdrop for all the child elements. Let me set a Z-index or something like that, because that's kind of hacky. So there's another property, but this is under discussion. Maybe this property will just not exist anymore. So basically, you just simply want to create a stacking context without any side effects. So the way you would do that is use isolation as a property. So you'll have a selector, and then you'll say isolation, and you will say that you want it to be isolated. So you'll use the property value isolate. And then that will form the backdrop for all the child elements that are using blend modes. So here is an example. So I have a H1, which has isolation set to isolate, and I have a background on it. And then I have a H1 span, and then I'll have the mix blend mode on that span element. And then I have a blend mode that's multiply. And so because there is no implementation yet for this property, I'm just going to show you an image of how that would appear. So here is the body and the H1, and then the span has a blue color. So the span is just a blue element. If you notice that that span, when it's interacting with the H1, it's showing some sort of multiplication effect with the background pattern that you see in H1. But when it's interacting with the background purple, whatever color that it is, violet maybe, I don't know, then there is no interaction at all. Like there is no multiplication effect that's happening. It's simply plain blue. That's because we have set the background blend modes to only be H1 and not the one behind it. So it's not blending with the body element, but it's only restricting its blending to the H1 element. So this is how you would create your stacking context without any side effects. So now if the H1, if instead of having the isolation property, if it had a Z-index or an overflow, the effect would still be the same. So this is about mix, which is the actual meat of the feature, which is the mix blend mode. There is also another feature that we are working on that we just had implemented as well, which is known as background blend modes. And in background blend modes, it basically allows you to blend multiple backgrounds together. So you'll have a background property, and you'll have multiple backgrounds. Maybe you have URLs. And you'll then specify the background blend mode to whatever blend mode that you want. So then now you can do any kind of blending with those backgrounds. So I'll show you an example of this. So here's a very ugly example, but this is all I could come up with in a very short notice. So I have a div, and I have two elements that are in two images in the background property. And if there is no blend mode applied, you will see that the images overlap. There is no like opacity or anything. They're just overlapping each other. So if I specify the background blend mode, now suddenly you see that there is a processing that's happening. So I can probably say screen. Wait. And you will see that how the overlap happens is changing. So I can say multiply, and that also changes thing, or darken, or color dodge. Let me see if that works. Yeah. So all of these things. The interesting thing to note is that it only blends between those two images that you specify in the background property and nothing else. It doesn't blend with the body element or the background of the body element or anything like that. So there is also blending that is available in Canvas, and we worked on this as well. There's just one simple property that you set, like global composite operation, and you specify that blend mode that you want to use. And this is something that is also shipping in Firefox Nightlies and also in nightly versions of, I think, Safari and Chrome. And here is how it would look like. So this is a CodePen.io demo. So suppose I don't have a composite operation, then all of these colors will be overlapping. But now I have a global composite operation multiply, so it's now multiplying the colors. So you can also apply all the other things like screen, and it'll start doing all the image processing for that as well. So there is sometimes some people have asked me, why do we need blend modes? Like, doesn't the filters feature already solve these problems? What's this need for blend modes as a separate spec? The thing is, filters can't create the similar effects, although filter does have a primitive called FE blend, which is supposed to take in some of these, like take in another image and then do a simple basic calculation with, I think, multiply and a few other effects, darken and things like that. But it doesn't do all the complicated stuff that the blend modes provide. And ideally, in the future, the filter primitive called FE blend is going to take advantage of the blend mode spec and provide those features as a filter, as a filter itself. So that is actually all I had for you. And for some reason, I finished too early because I was nervous. I do have to say, if you are interested in these features, if you have feedback, and if you think this is useful, talk to me or just follow us at Adobe Web. Or we have all the snippets that I showed you is on CodePen as well. So yeah, questions?
Hi, you showed the URL for the filters.
Yeah.
Can that just accept any also data URL or?
No, that's actually an ongoing concern. There's a course thing. Tab, do you know? Are you working on this? Because I saw this in the mailing list passively that Anna was mentioning that something about cross-domain stuff. But right now, you can mention any external URL. Right now, it would work, but I think there's concerns about cross-domain stuff. You know? Yeah. Hey, there's a mic there.
So the security concern about that is that you could use filters, regions, exclusions, I mean all the sort of new things we have in CSS to determine exactly the pixel-precise contour of characters or shape or whatever, and determine what is the content of a web page without having the right to read it. So it's again the kind of layout-based and pixel-precise-based access to content that we don't want to see in CSS. So some people argue that it's not really a security concern because you will get only the contour of data and not the real data. But for some people who are crazy paranoid about security, that's concerning enough.
Yeah, it's still an ongoing discussion.
I'm not an expert, I can't tell. For me, it seems like a weak security hole.
There's a question here.
You talked briefly about shaders, or
Yes.
do you have any examples of that? I mean, is that really a long way down the road, or
It
are we
is a
basically
lot.
going to have the equivalent of pixel shaders that we see in video games being written in CSS?
No, the shaders are not written in CSS.
Well, not the shader themselves, but declaring them via URL or something.
I can show you how this thing works. Okay.
Also, could we see those demos again? They were cool.
I'm sure they were. So if you notice here, let's probably look at the style. You have the filter, and you have this custom property, and then you have a URL that takes into shader argument. Then you have the functions. The syntax was supposed to be changed, but the thing is, then you would mix different shaders together, and then you may apply even blend modes on them, and then what would happen is that that particular image that is generated off that element would then be taken to the GPU, and the vertices will be calculated, and then all of these animations would happen based on what those shaders are supposed to be doing. So yeah, it's not gonna. So that's the thing. It would make shaders a lot more accessible than they are right now.
Cool. Thanks.
Yeah.
Hello, just one more question. The shaders and those effects, they look pretty complicated.
Yes,
and hard.
so there is, the spec has actually changed since that implementation to actually have like a filter rule and then define these things within a filter rule in a much neater manner. But because we are not sure how this effect, how this shader itself will be exposed, whether it's through CSS or maybe it's through some other context, we don't know yet because the graphics layer and how the browsers interact with them is still ongoing. It's fairly new, and we don't know how it's going to happen.
Do you probably have some solutions for a fallback? Could we somehow determine if the device is capable of running such a complex calculations in life, so that we could switch it on or leave it?
Conditional rules, that's the topic of the next talk.
Okay.
Yeah. Yeah, but I don't think you can detect the capability of a driver through a conditional rule. But I don't think we have anything like that right now. But yeah. Yes? Yeah, I can show that too. So there's another thing called CSS Filter Lab that we created to also play with the filters. So here you would have this crumple thing is a shader. So I can do perspective. Wait, let me just strength. Oh, OK. So clearly my driver is not capable of doing it. But I can do, the idea is you would use all of these filters that are custom filters. Maybe I can try something else. Dissolve. So you can see that the text is all being dissolved. I can do the amount that is dissolved by and all of these things. So these are the arguments that you pass to the, as you notice, if you were noticing here, these things change as I change the argument there. So you can use this to play around with shaders and find out like how what they're capable of and what you can do. Other question?
Thanks. I'm curious, how will this develop? I mean, what I'm looking at now is I'm not. This is not my job anymore. I mean,
yeah.
There's probably a
which
graphics
is why
guy.
it's far along. You don't have to worry about it right now.
No,
your
but
job is
you
secure.
understand what I mean, right? I mean, at some point, the designer is going to say he's going to build a design in Photoshop, whether or not we want it, and then he will say, "And here's the CSS."
Yeah.
And take the rest of the day off. What's your opinion on that? Is personal, or what does Adobe think about that?
Well, I can tell you what I think because I have no clue what Adobe thinks exactly. But my view is we are going towards using the web as a platform for creating any kind of user interaction, or that's how most users are now interacting with or doing things online on the internet. So there used to be that we had all these native applications, but now everything is moving towards the web. So if the web is not as powerful or as enriching an experience as using those native apps, then people are going to be disappointed. So if we want to provide these features, then if you want to make sure people are delighted in ways that they used to be with native features, native platform, then we should provide these features. So it's not about that also, it's also about developers who have been creating applications. They now move towards the web and they're like, feel constrained, which is fine because web is a different medium, but it's also a growing medium. So if you can provide greater control for getting that to happen, I'm all for that. Any other questions? Someone had a question here earlier. I don't want to feel bad. I don't want to make Peter feel like I'm... OK, cool. Thank you.